oxygen to be 16, which is 16. Okay, everything into N, which is out of 60, which is this is the relative molecular mass that was given to us from the calculation. Then if you add everything together, it's going to give you 30 N equal to 60, while our N will be 2. So that means the formula is CH2O into 2, which is going to give us C2, H4, and O2. This is our molecular formula. So we have calculated. Alright, so let us look at further example. A gaseous hydrocarbon contains 80% carbon and 20% hydrogen. 1 dm cube of the compound at STP weighs 1.5 gram. Find its molecular formula. 1 mole of any gas at STP occupies 22.4 dm cube. So we'll go the same way you're doing. Okay, draw the line. Okay, then we have our carbon, we have our hydrogen. Okay, so what is the percentage that's the percentage composition. So if you look at the percentage composition of carbon is 80, percentage composition of hydrogen is 20. Then we then divide with relative, that's the atomic mass. We divide with the atomic mass. Okay, atomic mass of both elements. So divide by the atomic mass. So we have atomic mass of carbon is 12, 80 over 12. The atomic mass of hydrogen is 1, that's 20 over 1. Then our answer will be 6.7, and we have this one as 20. So if we divide by the smallest number, okay, let's divide by the smallest number. This smallest number is here, so I can do 6.7 divided by 6.7. Then I'll do 20 divided by 6.7. Now once you do this, carbon is going to give me this is 1. You divide this one, it's going to give me 1, and this one is going to give me a 3. Okay, it's going to give me a 3. Now the empirical formula is then going to be C1, okay, C1, then H3, okay, which is a CH3. That's the empirical formula. And don't forget the molecular formula would then be CH3 into N, because it's in multiples, which is going to be equal to the relative molecular mass. Okay, going to be equal to the molecular mass of the compound. Okay, this is going to be it. Now we're given 1 dm cube of the gaseous compound. Say 1 dm cube of the gaseous compound. 1 dm cube of the gaseous compound weighs 1.35 gram at STP. Okay, weighs 1.35 gram at XTP. Okay, that's 1.35 gram weighs at STP. Now, what is 22.4 dm cube of the same gas weighs? Because the 1 mole of any gas at STP occupies this. So for us to find the relative molecular mass of the compound, we must now say 22.4 dm cube of same compound. What will it weigh at STP? Okay, will now be weighed, okay, 22.4 multiplied by this, 1.35 divided by 1. So this is going to give us 30.2 gram. Okay, so that means the weight of that compound at STP, which is the 1 mole of the gas, is 30.2 gram. So let's then now calculate the let me just take this one out. Okay, so don't forget we said that the compound is CH3N, okay, which is then going to be equal to this 30.2 gram. Then we then have the atomic mass of carbon is 12 plus atomic mass of hydrogen is 1. 3 times 1, that's 3. Everything into N is 30.2 gram. Then 15N will be 30.2, and we have our N to be 2. Okay, so then we then have our molecular mass to be CH3 into 2. So our molecular mass will be C2H6. Okay, this is our molecular mass, C2H6. Now let's look at another example. Now the percentage of carbon, hydrogen, and oxygen in vitamin C were determined by burning a sample weighing 2 milligram. That means the sample of that vitamin C, which is CHO, is 2 milligram. The masses of CO2 and H2O formed after burning the combination of this compound, the masses of CO2 and H2O formed are 3 milligram. That's the masses of CO2, and the H2O is 0.816 milligram respectively. From this, find the percentage of each element and the empirical formula of vitamin C. Now, let us take it one after the other. We know that mass of carbon, that is the mass, we need to, okay, now we know that the elements that we have in vitamin C are carbon, we have hydrogen, and we have oxygen. Okay, those are the 3 elements. They say we should find the percentage of each element and the empirical formula. So now let us start with carbon. Right. So if we're to find the mass of carbon, let us find the mass of carbon. Okay. Now, if we're to find the mass of carbon, we need to look at the mass of CO2, and the mass of CO2 that we're given, okay, mass of CO2 is 3 milligram. So for us to find the mass of carbon, we look at mass of carbon, okay, as in the percentage composition of carbon in CO2. If you look at the mass of in CO2, this CO2 contains 3 milligram, and we have oxygen in it, we have carbon in it. So for us to find the mass of carbon, we do the mass of carbon, which is 12, okay, over mass of CO2, okay, then multiply by 3, so that we know how much carbon is in 3 milligrams. So we're going to have 12, which is atomic mass of carbon, okay, over 12. This is 16 times 2. So 12 plus the atomic mass of oxygen is 16. Okay, 16 times 2 is 32. So we plus 32, then multiply by 3. So if we do that, we're going to have 0.818 milligram. Okay, that is the mass of carbon in the 3 milligram of CO2.
Now let us find the mass of, so we know this. Let's just let me just put it somewhere here. Then I know that, okay, the mass of carbon, mass of C, which I've calculated, is 0.818 milligram. Okay, so now let me quickly look at the mass of hydrogen. Okay, let's look at the mass of hydrogen in the water. Don't forget the mass of water that we're given. This mass of this is 0.816 milligram. All right, so mass of hydrogen will be this 2H. Okay, mass of 2H over mass, this mass of 2H over mass of water multiplied by 0.816 milligram. All right, so we have mass of hydrogen, 2 times 1. Atomic mass of hydrogen is 1. So 2 multiplied by 1, that's 2 over this. That's 2 plus 16. Oxygen is 16, that is 18, multiplied by 0.816 milligram. So once you do that, you're going to have 0.0916 milligram. All right, so okay, so now we've been able to find the mass of the carbon. We looked at the mass of the hydrogen, but we won't be able to calculate the mass of the oxygen. We don't look at the carbon, we look at the hydrogen, but we won't be able to calculate the mass of oxygen directly because we have oxygen in CO2 and we have oxygen that is produced also in H2O. Now, what do we now start? How do we now look at that? So we're going to find the percentage composition based on the mass that we've gotten. Okay, we're going to find the percentage composition. Now, when we start with percentage of carbon in 2 mg, so let us find the percentage of carbon. Okay, so in the 2 milligram of the whole compound, of the gaseous compound, don't forget this, what we're giving, sample weight of the gaseous compound, which is let's say the vitamin C. Okay, vitamin C rather. Okay, of the vitamin C. Okay, so we want to find the percentage of carbon. So we're going to do mass of carbon over mass, total mass of the whole thing multiplied by 100. So we've already have the mass of carbon to be this. So we have we then have 0.818 over 2, then multiplied by 100. So we're going to have percentage of carbon in 2 milligrams to be 40.9%. So we have that as 40.9%. Now let us look at percentage of hydrogen in 2 milligrams. The percentage of hydrogen in 2 milligrams. So it's going to have, we're going to have the percentage of hydrogen over the total mass. Total mass is 62, and percentage and the mass of hydrogen that we got from our the last one that we did for this one, we got 0.0916. So if you do that and also multiply by 100%, we're going to have 4.58%. So that means we have percentage composition of hydrogen and carbon. Hydrogen plus carbon is we have 40.9 plus 4.58. All right, so if you look at that, it's going to give you 40.67. All right, so what we then need to do to find the percentage of oxygen, So what we need to do to find the percentage of oxygen is to subtract the addition of hydrogen plus carbon. That's percentage composition in the compound of vitamin C. Okay, is to subtract it from 100. So we have write this one out. Okay, so we're going to have 100 minus 40.67 cents. And once you do that, you're going to have 54.3. That's 54 point. Okay, that's about 54 point. Say 4.5%. Okay, all right. So 5.4, 4 point, let's say 33, 4.33. Okay, 4.33%. Okay, so that is, we then have our, this is for hydrogen, this is for carbon, right? So now we can then find our empirical formula using the same method that we've been using ever since. So clear this one out. Okay, so let's find our empirical formula. Forget to draw a line. You have three elements: carbon, hydrogen, and oxygen. Then the percentage composition in the compound. We have this carbon to be 40.9. We have hydrogen to be 4.58. And we have oxygen to be 54.33. Okay, so then we divide by the atoms, that is the atomic mass, that's ratio of the atomic mass, that's the atomic mass, divide by the atomic mass. Okay, the atomic mass of carbon is 12, so 40.9 divided by 12. That's, this one is hydrogen, that's 4.58 divided by 1. And we have for oxygen, that is 54.37 divided by 16. Okay, so once we do that, we're going to have this to be 3.41. Okay, we're going to have this to be 4.58. Okay, and we're going to have this other one to be 3.39. So if you divide by the smallest number, we're going to have 3.41 divided by 3.39. Okay, to have 4.58 divided by 3.39. Okay, we're going to have then 3.39 also divided by 3.39. So if you do that, so you're going to have this 3.41 divided by 3.39, you're going to have 1. Okay, 4.58 divided by this is going to have 1.35, and you're going to have 1 here. Okay, so what that means is that hydrogen would have given you this is 1. Okay, this one was also 1, and this also is 1. So our empirical formula is CHO. Okay, and that is our answer. All right, so with that, we've come to the end of our topic on chemical formula. If you like this video, I want you to subscribe to our YouTube channel and feel free to share with your friends and loved ones. All right, so we'll see you in another series next week. I hope this has been very informative for you. Bye.